Today what you're learning is how to solve a system of linear equations by graphing. You've actually seen this before. In 8th grade you learned how to identify a solution from a system graphed on a grid. You just didn't know it as a system of equations. So today what we're learning about, like I said, is a system of linear equations. And so the definition for that is a set of two or more linear equations. Go ahead and try to create your own system of equations. In other words, all you're doing is you're making up two linear equations. You can write them in slope-intercept, standard form, or point-slope form. Here's the sample I created. 2x plus 3y equals 12, and y equals 2x minus 1. They're in different forms, but they are both linear equations, and together, these two equations are a system. You didn't have to pick exactly that as long as your two equations were both linear equations. So now we're going to talk about what is a solution of a linear system. Well, that's actually one of your vocab words, solution of a linear system. And the definition is a solution of a system of linear equations. Now, first of all, a solution is actually going to be a point. So in other words, it's going to have an x and a y. And the actual definition is an ordered pair that makes all equations true. Now, number 1, it says to prove that the point 25 is a solution for the following system. So these two equations that they've given us together form a system. And they're asking, is the point that they've given us a solution to that system? So what we're going to do is take the x value of the point and the y value of the point and plug them into each equation. So practice that with each of these and then check to see if you get it right. This is what you should have gotten once you plugged in both the x and the y values into both equations. Now let's simplify and see if we get true statements. 2 plus 5 is 7, and we bring down the other side, and 7 is equal to 7. Well, is 7 equal to 7 a true statement? Yes. So we know that that is a solution to that equation, but now we have to make sure it's a solution to both equations. So 2 times 2 is 4. Negative 3 times 5 is negative 15. And we bring down the equals negative 11. I'm going to move over here, and we get 4 minus 15, which is negative 11. And we bring down the other side equal to negative 11. Is negative 11 equal to negative 11? Yes. So they are both true statements. Therefore, the point that they gave us is a solution to the system. Now pause the video and try number 2 on your own and do exactly what I did on number 1. If you plug in the point and get a true statement for both equations, it is a solution to the system. If one or both of the equations are not true statements, then it is not a solution. For the first equation, we get that 0 is equal to 0, and that is a true statement. But for the second equation, we get 0 is equal to 2. That is not a true statement because 0 will never ever be equal to 2. So because one or of the equations is not a true statement, then this point negative 2, 0 is not a solution.